In this video, we are going to solve a couple system of equations using elimination. Okay, we are not going to actually graph it. Did that on a previous video just to kind of show and compare. But it's kind of an inefficient way to solve systems of equations. So we're going to focus on just kind of the more efficient routes, which are elimination and substitution. So this video is going to be focused on elimination. So elimination is you're going to want for your system of equations to be in standard form. So x's and y's on one side and then constants on the other. And we are going to line them on top of one another. So we're going to line up our like terms. All right, so you got a 3x plus an 8y equals a 7. And then the other equation is a negative 3x minus a 3y equals 8. All right, so our goal here is to eliminate a variable. And we're going to do that by combining like terms. So we're going to combine our x's, we're going to combine our y's, and we're going to find our constants. Now, if they don't just naturally cancel, then we're going to have to manipulate it a little bit. But right now, the x's cancel, which is fantastic. So we will combine our x's, the x's go away. We can put our y's together. 8y minus 3y is 5y. And then the 7 and the 8 makes 15, which then I can finish by dividing by 5. Okay, so our y value is going to equal 15 divided by 5, which is 3. All right, and then I want to figure out what the x value is, because the idea is that these both are lines, and I want to see where they cross, so I need a coordinate to it. So right now we have a y value of 3. I just don't know the x value that goes with it. So I'm going to select one of the two equations to replace my y. I'll do that one just because it doesn't have any negatives. So I'm going to replace that y with 3. So I have 3x plus 8 times 3 equals 7. So 8 times 3 is 24. So 3x plus 24 equals 7. Subtract the 24. All right, so that goes away. You're looking at a 3x equals 7 minus 24 is negative 17. Now, bad news is we're going to divide by 3, and it's not going to work out clean. And this would have been a total limitation to if you were to try to graph this. So we got a negative 17 thirds. So our solution is negative 17 thirds, comma, 3. So if we graphed them, that's where the graphs would cross each other. It also should be solution. So if I take this answer and plug it back into this original that we just used, it should add up to 7. But I'm going to check the other one. Okay, I always check the other one to make sure that we didn't get lucky on this. So I'm going to plug in negative 3 times this x value of negative 17 thirds minus 3 times the y value of 3 is supposed to make 8. Okay, well, it looks worse than it is to multiply this together. Negative and the negative are going to cancel. And the way I multiply a whole number times a fraction is 3 divided by 3, which is 1, times 17 is 17. No fraction anymore. Minus 3 times 3 is 9, equals 8. 17 minus 9 equals 8. So I know that that works. Without graphing it, I know that that's where they would intersect each other. Okay, now that one was good because the x's were kind of set up to cancel. Not always the case. So that means sometimes we have to manipulate it a little bit. Okay, so if we look at this one, we have 2x plus y equals a 7 and an x plus y equals 3. So what I'm going to try to do is the x's and y's don't just naturally cancel. So that means I got to manipulate. And so if I look at this problem, either I can cancel the x's or I can cancel the y's. It's totally up to you. I look at it and say, well, the y's could cancel pretty easily if I could just make one of them a negative. And so I do that. So I'm going to take a negative and I'm going to distribute it to everything. So if I want to change this sign, I have to change all their signs. It's kind of an all or nothing. So the top equation, nothing happens. So that's just a 2x plus y equals 7. The bottom equation, all of the signs are switching because I'm distributing a negative to everything. Now the y's go away. So now I combine my like terms. 2x minus x is x. And 7 minus 3 is 4. Great. But I want to figure out the y value. So I'll pick one of these two equations that I think is easier to work with. give me that. And I know my x is 4. So 4 plus a y value is supposed to make 3. I subtract 4. My y value is going to be 3 minus 4, which is negative 1. So my coordinate is 4, negative 1. So without graphing, that's where they would cross. And I would most likely double check that it works. 2 times 4 is 8. Plus a y value of negative 1 does in fact make the 7 that we're looking for. Okay, but notice how I didn't reuse the problem that I just finished with. I'm going to go back and check the other one, make sure it works for that as well. All right, one last is sometimes, let me write it down. So there's one equation. My other equation is 3x plus 4y equals 2. All right, so I try to pick a variable that I would like to cancel. I'm either going to cancel my x's or cancel my y's, but if I put the x's together, I get a 5x or a 7y. So right now, nothing cancels. So I need to manipulate. Sometimes I have to manipulate both equations. So I'm really just going to look at do I want to cancel my x's or do I want to cancel my y's? And in order for them to cancel, they need to be the same. So what could I make 2 and 3 both become? Or what could I make 3 and 4 both become? Ideally, I'm going to pick the smaller of the two. So I can make both the x's into a 6. I can make both the y's into a 12. So I think that 6 is some lower numbers will be a little bit easier route to go. So I'm going to multiply the top by a 3. I'm going to multiply the bottom by a 2. The problem with that right now is I'm going to have a 6x and a 6x. They won't cancel. So one of them I need to put a negative on. So one is going to be a negative 6 and one will be a positive 6. So if I distribute this into every single piece, that's going to become a negative 6x. Then I'll distribute it to here. So that's a minus 9y. And then I'll distribute it to here, which is a negative 3. I'm going to distribute a 2 into this equation. So that's a 6x plus an 8y equals 4. All right, put it all together. 6x's cancel each other. Negative 9y and a positive 8y make negative y equaling a positive 1. I'll divide by a negative 1 to cancel away the negative, which makes our y value a negative 1. Okay, so I have my y value of where they cross. I just need the x value of where they cross. So I am going to select this equation. I feel like my numbers are a little smaller. So I'm going to take the negative 1 for the y and sub it in. So 2x plus 3 times negative 1 equals 1. So this 3 times negative 1 is a negative 3. And now I can solve my equation. I'll add 3 to the other side. 2x equals 4. Divide by 2. X equals 2. Okay, so I have a coordinate of 2, negative 1. But I'd like to double check that it works. So I think that this is the solution that's going to work for both. I just got done using this one, so I'm going to check this one. So 3 times 2 is 6. 4 times negative 1, negative 4. And does that add up to the 2 that we're looking for? Yes. And that's it. So I know that that's the solution. So that's a couple of solving systems of equations with elimination. Again, the trickier ones are when you have to manipulate both variables. But we could have started the whole process by eliminating the y's and not the x's. It's totally up to you and what you kind of see and makes the most sense for you.